my name's Pete Puleo. I'm a third-year PhD candidate working with Professor Yarrow Axford, and today I'll be talking with you all about Younger Dryas and early Holocene climate change in South Greenland inferred from lake sediments. So overall, I'm really interested in climate change from the last glacial maximum through the early Holocene. And more specifically, I'm focusing on the Younger Dryas, which is a period of abrupt change in terms of temperature and in terms of ice sheet dynamics in the Northern Hemisphere. One specific characteristic of the Younger Dryas that I'm interested in is regional variability in terms of how much climate change is happening in what region of Greenland, North, Central, or South Greenland. So to answer some of these questions, we went to Lake N14 of South Greenland. This is a really ideal site for adding to these iconic Greenland ice cores because it's near the southern tip of Greenland and very close to the North Atlantic, which is thought to play a major role in the cause of the Younger Dryas event. And more specifically, changes in ocean circulation brought about by ice sheet melt, inhibiting the flow of warm water from the equator up to just off the coast of South Greenland. Also, Lake N14, our site that we focused on, is one of the only places in Greenland known to contain an entire record of Younger Dryas age sediments in Greenland. So what did we use in the sediment to reconstruct climate changes? Well, my incredible artistic ability here shows you we have these insect parts and aquatic mosses. These are well preserved in the sediment core over time, and when they form, they record a snapshot of lake water values, and more specifically, delta 18O values. These lake water delta 18O values are influenced by precipitation delta 18O values, which are changed generally by changes in climate. Here are some results of the delta 18O measurements on those proxy materials. In orange, we have the chironomid head capsules, which are the insect parts. In purple, we have moss cellulose extractions from the aquatic moss. And in green, we have bulk moss delta 18O values. At this Younger Dryas to Holocene transition in our site, we see an increase of about 5 per mil from the chironomid head capsules, and an increase of around 7.5 per mil from the bulk moss and moss cellulose values. Now, these two panels below here are Greenland ice core records. The black line is from central Greenland, and the gray line is from South Greenland, but somewhat far north of our site still in South Greenland. The change here in terms of per mil is around 3.5, so fairly significantly smaller than the changes that our proxies record. And in northern South Greenland, the change is around 4.5 per mil, so still lower than our proxy reconstructions. So this suggests that there may be greater changes in terms of temperature or precipitation seasonality in very far South Greenland, consistent with the cause of the Younger Dryas being ocean circulation changes in the North Atlantic. Thank you.